Now, two soils with the same pH, let's say we have soil 1 with a pH of 5 and soil 2 with a pH of 5, they can be vastly different in terms of their lime requirement. Lime requirement being the quantity of lime necessary to adjust the pH of that soil upward to a given level. So let's say we had two soils with a pH of 5 and we wanted to adjust the pH of soil number 1 up to a level of 6.5, and we wanted to do the same thing for soil number 2. One of these soils might require 3 tons of lime per acre to make that adjustment, whereas the other soil might require as much as 5 or 6, or nearly twice as much quantity or tons of lime to adjust soil pH to that given level. Why could that be? Well, soils that have the same pH, remember we're measuring only hydrogen ions that are in solution or the active acidity, can vary greatly in terms of their reserve acidity. Reserve acidity being those hydrogen ions that are being held on the exchange site that can be displaced, go into solution to be a part of the active acidity at some point in time. So in the example that I just gave you, if soil number 1 had a low level of a low level of reserve acidity, then that soil would require less lime quantitatively than would soil number 2 that had a high level of reserve acidity to offset or neutralize that hydrogen. In other words, lime not only has to help offset or neutralize the effect of the hydrogens that are in solution, it must also be able to counterbalance or offset the hydrogens that are on the exchange sites, because of course calcium going on to the exchange sites will drive those hydrogens off. And we have that many more hydrogens going into solution that we must therefore neutralize or offset the acidity effect from. So that helps explain why lime requirements can vary dramatically from one soil to another, even though we have similar pHs and similar levels to which we want to adjust the pH of those two soils. Now, there are some materials other than lime that can be utilized to adjust soil pHs upward, but irregardless of what that particular type of amendment or material is, its effectiveness is always evaluated in terms of the lime requirement, or lime equivalency, I should say. So all of the materials that are used to adjust soil pH are evaluated in terms of their effectiveness in comparison to calcium carbonate or pure lime. And it may take quantitatively more or less of that particular material to adjust the pH to the same degree or effectiveness that calcium carbonate or lime has in adjusting that soil pH. So what I would like you to understand about what we've just talked about on reclaiming alkaline and or acidic soils is what is the chemistry involved in this process. In other words, how is it that gypsum can be utilized to modify or lower the pH of an alkaline or sodic soil? And how is it that lime or calcium carbonate, or could it be dolomitic lime, calcium magnesium carbonate, how are these materials effective in reducing the pH increasing the pH of acidic soils? So once again, alkaline soils, we're lowering the pH. What's the chemistry involved there? And in acidic soils, we are raising the pH. And how is lime effective, and what chemistry is involved in that process of increasing soil pH through applications of liming materials?